Here is the question 11. It reads, in the figure, a line of electric field created by 2-point charges Q1 and Q2 is shown. So this is the field line that have been shown due to these two charges. Out of several field lines, one line has been shown. It says Q1 is known to us. Estimate Q2, that means find the value of Q2 to the closest value out of 4 options. All are negative. So we can think of this Q2 needs to be negative because Q1 is positive. Why so? Because field line is terminating from one point and emerging from one point. So basically they are connecting the 2 points. So it's like from one charge it must be going towards another charge, and it happens like they emerge from the positive charge field lines and terminate towards the negative charge. Since Q1 is positive, so field line must be like this and reaching to Q2. We can also have this field line, one more field line, and there can be a number of field lines in similar fashion. So we need to use this field line and then decide about Q2. So Q2 must be negative, that is valid as per the properties of field lines. So I have just redrawn the field line over here, and one more field line I have used this much. Let's consider this tangent at this point if you draw, and this angle is alpha. And if we draw a tangent over this point and consider the angle as a beta. So we can say all the field lines which are emerging from Q1 must be reaching to Q2. That's what we can say, which means from this beta angle, whatever the field lines are emerging, all are being absorbed at alpha angle. Now this is only in one direction. We can complete it by using like this. So we can say it will be like the way field lines behave upside, similarly they are going to behave downside. Moreover, we can rotate it with this, so we can get a 3-dimensional envelope, and in this 3-dimensional envelope, all the field lines emerging from Q1 need to be reached at Q2. So we can say if we try to find the flux through this solid angle, the same flux is going to pass through this solid angle. So flux of Q1, we can claim flux of Q1 is going to be same as the flux of Q2 through these solid angles respectively. Now to make it simpler, we can think of a cone that is going to be created by having semi-vertex angle as beta will have the same flux as the cone that is being created by having semi-vertex angle alpha for Q2. So that's what I have written over here. Now we know if we have a solid angle, so let's say this entire solid angle is omega1, this entire solid angle is omega2. So we can say the flux from due to Q1 is going to be equal to flux equal to of Q2 with these respective solid angles. And we know total flux is Q1 upon epsilon naught in the closed surface, and the proportion of this solid angle is sigma 1 by 4 pi. So this is the flux of Q1 through this solid angle. Similarly, this is the flux from that is going to go into Q2 through that solid angle corresponding to alpha. Now there's a minus because Q2 is going to be negative, or you can say it's because from this flux is going outward, from this flux is going inward. So minus will take care of the sign. Now this 4 pi epsilon naught will get cancelled out, and we can find Q2 upon Q1 is equal to minus omega 1 upon omega 2. And for cones, we can write it as like 2 pi 1 minus semi-vertex angle, which is which is beta for one, alpha for another. Now 2 pi further gets cancelled out, and it's like 1 minus cos beta divided by 1 minus cos alpha. Now from using this figure, we need to identify what these alpha betas are. Once we are able to identify alpha and beta, we can simplify these and we can get the ratio of Q2 upon Q1, and then we know Q1, we can find Q2. Now let's use this picture. In this picture, if we draw a tangent at Q2, then you'll find it will be meeting somewhere here, and we can use this right angle triangle which I have drawn here for alpha. So you'll find these are going to be 1, 2, 3, 4 units, and you will have a 1, 2, 3 unit here. So 4 and 3 we have copied from there. So we can find this is going to be right angle triangle and hypotenuse will be 5. So cos alpha is clearly known to us. That's going to be 4 by 5. So point is we got to know the denominator. And we will be writing 1 minus cos alpha as 1 minus 4 by 5, which will simplify as 1 by 5. Now we need to find beta. So for beta we can use this triangle because we need to find closest. So we are just trying to make this rough situation. Now beta is going to be this entire angle up to the tangent. So this is a tangent. So we can say this is going to be 90 plus this angle. So this triangle has been redrawn over here. See carefully. Now beta is going to be up to the tangent and this is going to be 90 degrees. So we can measure this angle, which is, let's say, gamma. And if we know the gamma, so beta is going to be 90 plus gamma. Now here roughly you will find 1, 2, 3 units you need to go in this manner, and roughly 1 unit over here will do the job. So that's going to be 2. It's close we are talking about. So if it is 2, it is 3. We can find the hypotenuse using Pythagoras. So it's going to be like root 13. So cos beta could be replaced as 90 plus gamma. And cos 90 plus something is minus sine, so that minus and minus will become plus. So it becomes basically 1 plus sine gamma upon 1 minus cos alpha. Now sine gamma can be identified out of it. Sine gamma is going to be 2 divided by root 13. So it's going to like minus outside 1 plus 2 upon root 13 divided by 1 minus 4 by 5. Then you can simplify this number. This number comes out to be close to 7.77. So we can say this is close to 8 basically. Q1 is 1 microcoulomb, so you'll find this Q2 will become close to minus 8 microcoulomb, that is 7.8, or you can say roughly minus 8 microcoulomb, which is closest to D option. Hence D option becomes the correct answer. Thank you.